Hi, I'm sorry I'm not able to be with you guys today. Mrs. Davies and I are on the Secondary 2 field trip, but I would like to take a few moments to talk about some properties of numbers with you. I don't know if you've ever heard of the commutative property or the associative property or the distributive property. The distributive property I think is pretty easy to understand in a way. For example, I just recently was selling donuts for my little boys' preschool classes. So when they arrived, I had the job of distributing the donuts to all the people who had made the purchases. So distributive property is it just means that you've got some value and you're just distributing it to each individual piece. So we'll see what that looks like. The commutative property is comes from the word commute. Commute, you can think of that like you might have to commute to school, you may have to go back and forth, you might have to travel a certain distance. But the way we're going to look at commutative is that it means that you can change the order of something but still get the same value. Or you can change your order. We've talked about order of operations, but sometimes it's okay if you change the order, and that's what the commutative property talks about. And then the other one is the associative property. The associative property says that in certain cases it's okay to change how you group things. So rather than doing maybe the first two numbers first, it's okay if you rearrange it, maybe if you put move your parentheses around so that you can change the way that you group. Alright, so let's look at some examples. So at this point you need to have your class notes for number properties in front of you, and we're going to be working through some of these examples together. So if you don't have your number properties notes in front of you, you need to pause the video and find them, get them out, and be ready to take notes. The first one we're going to talk about is the commutative property. Now notice that there is no N in this word. That does not say commutative. A lot of people call it that, but that's not what it means. Commutative. Okay? And it states that changing the order of add-ins or factors does not change the sum or product. Now what does it mean when it says an add-in? An add-in would be a number that you've added. So for example, 3 plus 2 equals 5. 3 and 2 you would call add-ins. Those are the numbers you're adding together. Factors are numbers that you're multiplying. So maybe 6 times 2 equals 12. So 6 and 2 are your factors. So what this is saying is that anytime you add two numbers together, or if you multiply two numbers together, changing the order does not change the answer. So, and you probably know this, really, you just didn't know that this had a name. So 3 times 2 is the same thing as 2 times 3. 4 plus 7 is the same thing as 7 plus 4, okay? So we're just going to say the same thing, but it's okay. You can also use negatives and positives to say this. So in your notes, you should see negative 5 plus 8 equals 8 plus negative 5, okay? Or negative 5 times 8 equals 8 times negative 5. So the commutative property simply allows us to change the order of numbers that are being added or being multiplied. The second property is the associative property. Okay, the associative property just says that we can change the way things are grouped together sometimes. Changing the grouping of add-ins or factors does not change the sum or product. So here in this example, you'll see you've got 7 plus 4, and it's inside parentheses, and then plus 2. So that's saying that you know from order of operations that you do the inside of the parentheses first. So this is saying that if you added 7 and 4 first and then added the 2, you'll get the same answer as if you added the 4 and the 2 and then added the 7 last. So we just changed the grouping of what we wanted to do first. Now we did not change the order. It's still 7, 4, 2, 7, 4, 2. We just changed the grouping. So that's the associative property. Same thing holds true with multiplication. 7 times 4, and then if you multiply that by 2, will give you the same answer as if you first multiplied 4 and 2 and then multiplied 7. Again, order did not change. The only thing that changed was the way that we approached the problem and what we did first. Okay, now these properties are very useful because they can help you do problems faster. They can help you with mental math. So in example 1, I want to evaluate 4.7 plus 6 plus 3.3. Okay? Well, it might be easier if I notice they've got a 7 here and a 3 here. So in the tens place, we've got a 7 and a 3. That's easy to add. That gives me, I know 7 and 3 is 10. And then I would need to carry my 1, and I would add 4 and 3, and add that 1. So 4.7 and 3.3, I can add that easily in my head. So what I'm going to do, I'm going to use one of my properties to rewrite this as 4.7 plus 3.3 plus 6. Now what did I do there? I rearranged it. Did I change the grouping or did I change the order? Or the 6 and the 3.3, or the 6 and the 3 and 3/10, they got reversed, so the order changed. So this is the commutative property. So beside this, I'm going to say that I used the commutative property. And I'm out of space there. And then 4.7 and 3.3, I can do that in my head. That's 8, or 8.0. So that's just 8. And then I need to add my 6. 8 plus 6 all I'm going to do now is just add. Nothing special. 8 plus 6, and my answer is 14. So it was the commutative property that said that I could change the order. And it was easier to add 4.7 and 3.3 than it would have been to do 4.7 plus 6 and then add that. So let's look at part B. It says evaluate. In parentheses, I have 7 times 4, and then outside I've got 1/4. Now you'll notice there's nothing between the parentheses and the 1/4, so that means it's being multiplied. Okay? Well, 4 times 1/4 is easy to do. I hope that you see that 4 times 1/4 is just 1 because it's a reciprocal. So instead of doing 7 times 4 first, let's change this. Let's do 7, and then let's put the parentheses around 4 times 1/4. So that means I'm going to do 4 times 1/4 first. Now, have I changed my order? No, nothing's changed. No, the order has not changed. I'm still doing it the same numbers left to right, but I'm going to start in a different spot. So the grouping has changed, but not the order. So that means I'm going to use the associative property. And I really should say it's the associative property of multiplication, to be really precise here. Associative property of multiplication. Okay, and then I'm going to do the parentheses. 4 times 1/4 gives me 1. And 7 times 1 gives me 7. So all I did there was just multiply. And my answer is 7. And I'm just about out of space there. Okay, so you should have written the same thing in your notes. Pause if you need to so you can catch up if necessary. Now we got some practice. So we want to, it says evaluate the expression, explain each step. So in number 1, we've got 2 plus 3 plus negative 2. Okay, just looking at this, I know that 2 plus negative 2 is really easy to do. So I'm going to change them around. I'm going to write 2 plus negative 2 plus 3. 2 plus negative 2 is 0. Well, before I do that, though, I need to explain my step. What did I just do? I changed my order. So I used the commutative property. I used the commutative property of addition. I'm abbreviating there. And now I'm just going to add 2 plus negative 2 is 0 plus 3. So my answer is 3. And my last step was that I just added. So add. Alright, now I'm going to leave the even ones for you to do. I'll give you time to do them and then I'll give you the answer so you can check yourself. Number 3, 4 times 19 times 1/2. Alright, well I noticed that 4 times 1/2, that's easy, because that means half of 4. So let's do that first. So in order to do that first, I need to rearrange some things here. I'm going to say 4 times 1/2 times 19, and because I changed the order, I'm using the commutative property. And this time it's of multiplication, because we're multiplying. Now I'm going to do 4 times 1/2. Well, half of 4 is 2. So 2 times 19. And now I'm going to just multiply. 2 times 19 gives me 38 for my answer. Number 5. I've got 5, and then in parentheses I have 7/8 times 2/5. Now, Because we've been working so much with fractions, I know that I can reduce factors crossways. And I notice I've got a 5 here and I've got a 5 in the denominator. So I think it might be easy if I just started with 5 times 2/5. So what can I do? First, I'm going to remove the parentheses. I'm just going to take them out. And I'm just going to say 5 times 7/8 times 2/5. Okay, I've not really used a property yet, but I do want to I want to move my 7/8 and my 2/5. I want those to trade places. So I'm going to say 5 times 2/5 times 7/8. I just used the commutative property of multiplication. Okay. And then I'm going to put the parentheses around these two because that's where I want to start. Okay, so now you could also say that I've also changed my grouping because I moved the parentheses. So I'm going to do 5 times 2/5. Well, 5 over 1 times 2 over 5, those 5's reduce, so I'm left with 2 times 7/8. And I also use the associative property of multiplication. Okay. And then I can simplify this. 2 and 8 have a common factor of 2. 2 goes into 2 once, 2 goes into 8 4 times. So I've got 7 over 4, 7/4, or 7/4 is okay. And let me zoom in, I don't know if that's showing up very well, but 7/4 is an acceptable answer. That's okay because it is simplified. There's no common factor. If you wanted to write it as a mixed number, you can. You could write that as 1 3/4. So either one of those will be acceptable. In algebra, we tend to prefer the improper fractions. Okay. Now, I want you to do the even problems on your own. Pause the video. Okay, here's your answer to number 2. Let's check yours. Answer to number 4. Check your work. Answer to number 6. Any of these that you missed, I'd like you to pause the video. I'd like you to do the problem again and see if you understand where you went wrong. Example 2 gives us a real-world application. A helium atom has positively charged protons and negatively charged electrons as shown in the diagram. The sum of the charges gives the charge of the helium atom. Find the charge of the atom. Okay, so with the electron, we have -1 and a -1, and then we have protons that have values of +1, +1. So we're just going to add these together. Okay, now you've just learned that you can do these in any order that you like. So -1 plus 1, that's 0. And then over here, and I wrote -1, but I probably should have said plus -1. Either way is fine, but if I write it as plus -1, so I had -1 plus 1 plus 1 plus -1. And then I can think of the associative property. I can group these together. 1 plus -1 gives me another 0. So I get 0 for my answer. At this point, for your assignment for the rest of class, you do not have homework for this lesson, but for the rest of class today, you should go to your textbook, page 67B, and you should do practice problems 7 through 9.